Hello everyone, I'm Anirudh Chirati and I'm presenting on behalf of Team 11. This presentation is about Big Data project, that is loss ratio prediction for auto insurance policies. Let me share some information about auto insurance business. Auto insurance is a contract between an individual and the insurance company that protects the individual by providing property, liability, and medical coverage. The business problem is around 10 to 50% of the insurance policies are mispriced, and due to this reason, the insurance companies are suffering loss. We have to optimize these mispriced auto insurance policies by calculating loss ratio. Given a policy with premium amount and other attributes, our goal is to build a machine learning model that can predict the loss amount for the particular policy, which can be used to calculate the loss ratio. With this, we start the first step, that is, we perform data exploration to identify variables, data types, conduct univariate, bivariate, and multivariate analysis on the dataset, identify missing values, outliers, incorrect values, etc. Since data quality is very important, our next task is to pre-process and prepare the data to be usable as an input to the machine learning model. For data cleaning and preparation, we first deal and handle the missing data. We observed that many columns had missing data. There were some columns which had greater than 90% of the missing values. In the real world approach, it is better to communicate with the business and ask for the data rather than imputing such data. Since we cannot communicate with this business in this scenario, it is better to drop such columns. Therefore, we decided to drop the columns which had more than 90% of the missing data. Some of the columns were not present in the testing dataset, like claim amount, frequency, severity, loss ratio. We dropped such columns because we cannot train the machine learning model with features not present in the testing dataset. There were some redundant columns as well, and some zip code columns which cannot be imputed, and there were a lot of missing values in these columns. So we decided to drop these columns as well. We removed outliers in the vehicle bodily injury limit column and merged the ranges. We also merged the ranges for EEA prior bodily injury limit to avoid multiple dummy columns of encoding. For vehicle symbol, according to the business, the range is between 3 to 27. As we can see that there are also values like -1, 1, 2, which are less than 3. These values we replaced with 3. Vehicle days per week driven had -1, 8, 9 values, which are greater than 7, which is not possible. Therefore, and most of the values in this column were 5. Therefore, we decided to impute or replace the missing values with 5. Vehicle miles to work had 40% of the missing values, and there were no other attributes which can be used to perform KNN imputation. Therefore, we use the next best approach, that is random replacement of missing values for vehicle miles to work. Vehicle annual miles had all the incorrect values. According to the business, it is possible to compute vehicle annual miles to work using the formula vehicle miles to work and vehicle days per week driven. So we applied that formula to obtain vehicle annual miles and populated all the columns in vehicle annual miles. Vehicle MedPay limit, vehicle physical damage, these two columns are optional add-ons, and it is up to the individual to decide if they want to add to the insurance policies. Therefore, the people who do not have this added to their policies won't have the amount mentioned. But since the amount cannot be negative, therefore we replace these values with 0. After data preprocessing, after handling these columns, there were also two columns, vehicle passive restraint and vehicle anti-theft device, which had related variables. Therefore, we decided to impute the few missing values which these two columns had with KNN imputation. Post data preprocessing, we have we have to perform data scaling and encoding. For all the numerical data, we implemented data scaling. For categorical data, for all the categorical data which had greater than two categories and which were ordinal, we performed label encoding. And for the categorical variables which had greater than two categories and which were nominal, we performed one-hot encoding. There were also features, around 15 features, which had two categories. For them, we performed binary encoding. For all the data imputation, data missing data handling, and data preprocessing, we refer the business. These are the resources to the business logic and business information. Post data cleaning and preparation, the model is ready to be given as an input to the model. Which model are we going to use? That is a question. Since we want to predict a continuous dependent variable loss amount from the number of independent variables, we decided to implement regression model to the preprocessed data. Initially, we implemented a linear model, then we implemented random forest regression. The linear model did not perform well, whereas random forest performed better than the linear model. To confirm the consistency of the prediction and the accuracy, we implemented k-fold cross-validation and confusion matrix, which helps us gain confidence in the model we developed. We also used hyperparameter tuning to make sure that the model doesn't overfit on the training data and performs well on the unseen data. With this, I would like to conclude the presentation, and I would like to thank Dr. Gabriel Terejano on behalf of Team 11 for giving an opportunity to implement the knowledge acquired in the form of course project. I also appreciate the equal contribution of all team members in the implementation of this project.